model for representing any spatial phenomena along with attribute. One is a raster, another one is a vector. Raster is also called as a composite model, and the vector is also called as a georelational model. Now these two models are having their different characteristics. They are having their own advantages and disadvantages, and they are having a different file structure. So whenever you are working with any application, you have to see what are the advantages of using a raster model or what are the disadvantages of using either raster or vector. Now if you see, you can easily visualize these two, this picture wherein the real world is depicted, and you can see a vector model as well as a raster model. You can see that there is a forest, there is a water body, and there is agriculture, and all these phenomena, how they are being represented in a vector as well as in raster model. So you can yourself see in a raster you may be seeing a pixels or a picture element, and in a vector you could see a very good different very beautiful shapes which are organized in a vector. Now in both the raster as well as in vector model, you can store your data by making use of a regular tessellation, by making use of irregular tessellation, point data, line data, and area data. Now these all 5 are called as the spatial data types in order to store any real world phenomena. Now regular tessellation and irregular tessellation, they are under the category of a raster model, while point, line, and area, they are the categories of the vector model. Now if you see, in the tessellation is something like a mosaic of similar shaped cells, while in irregular you have a mosaic of different sizes cells. So like in regular tessellation, you can have the example of a satellite data wherein you have different number of pixels, and these pixels are of equal sizes. But in irregular tessellation, you have different sizes of pixels, but they are mosaic, but their shape is same. But in point, line, area, we don't have those mosaicing sort of thing. But point, line, and area, they are the independent entities which can be stored in a vector data model. So we'll talk in detail about this one by one. Now let us talk in detail on the vector data concept. Now as you already know that vector, you have 3 types of data which you can store in a data model. One is a point, another is a line, another one is a area. If you see a point is a 0-dimensional because it is having a single coordinate pair without any dimension. That is, it is dimensionless. You can have different type of categories under point, like you can locate a particular tree, oil well, anything you can use for point data. Then under the line data, you have, it is a single dimension and it is having 2 or more connected XY coordinates, wherein you can have a length wherein you have only 1 dimension, and here you can have 2 or more coordinate pairs. So you can start with 1 point, 2 points, so you can have n number of coordinate pairs. But in polygon is supposed to be 2-dimensional because it will have an area, because it is a closed polygon. So 4 or more ordered and connected XY coordinates are possible. You can see the figure. Now you can see in a polygon you start with 7, 2 and you end with 7, 2, means that that polygon is closed. If I remove this 7 and 2, this will not remain as a polygon, but it will be called as a line. So the moment I put this, it becomes a closed polygon, and it will be having an area. So it will have minimum of 4 or more ordered and connected XY coordinates. So first and last XY pairs are the same. It encloses an area, and it can be used for many applications. Like in point, you can represent any point phenomena which is available in the real world. Then you can also represent any phenomena line, like road you can represent, or some electricity lines or streams. All those things could be under the category of line. While in the polygon you can have the land use, land cover map, forest type map, and you can have anything which is represented by a closed polygon. Now the same thing is in the point, you have XY coordinate pair plus label. Line is nothing but a series of points, and area is also a series of points, line forming their boundary, and series of polygons. So you will have all the polygons which are closed. Now just you can have a look to this figure. You have in this particular area, you have all point, line as well as polygon. Point is represented by a single coordinate pair, and you are giving the attribute as well. And if you see B is also a combination of n number of coordinate pairs. But the thing is, you have a series of coordinate pairs, but it is not closed. So that's why it is called as line. If you see C, you start with 4, 3, you end with 4, 3, means it is a closed polygon and is attributed with a different, like lake here we are putting. So this is a closed polygon. Now the very important thing is, here you have latitude and longitude. So you are representing this with the help of x-axis and y-axis. So they are all coordinate pairs. Now coming to the line type, we know that line segment is nothing but it comes with two endpoints. Line string is a sequence of line segments, means under a line string you can have n number of segments. So line string will have n number of segments, means it will have n number of vertices. But in a line segment you will have one starting node and one ending node. While in linear ring, a sequence segment with a closure. So you have a spline sort of curve wherein you may have n number of more vertices compared to a simple line which is not closure. Okay, so here you have more number of vertices under a linear ring, a sequence of segment with a closure, which means it is closed. While you have a curves are also like arc. They are arc, or you can say a simple segment. Sometimes arc refers to lines under ArcGIS or ArcView. Now let us talk about the data structure. Now now this particular thing is very important. Why it is important? Because how you will store this data in order to have a good performance. And also the queries, whenever you fire a query or I should say any overlay analysis. Now these analyses are more governed due to the data structure. If your data is stored in a very organized data structure, your query, your relationships, your attribute information extraction will be optimal. So in order to have a better performance, you always try to organize your data into a proper way. Like in vectors, you have different way to organize the data. Like one is a spaghetti structure, which